Dear students, today we are going to discuss about radiation dosimeters. What are radiation dosimeters? A radiation dosimeter is a device, instrument or system that measures or evaluates either directly or indirectly the quantities exposure, karma, absorbed dose or equivalent dose or their time derivatives or related quantities of ionizing radiation. A dosimeter along with its reader is referred to as a dosimetry system. Measurement of a dosimetric quantity is a process of finding the value of the quantity experimentally using dosimetry systems. The result of a measurement is a value of a dosimetric quantity expressed as a product of a numerical value and an appropriate unit. So let us discuss the properties of dosimeters. The following are the important properties of dosimeters. They are accuracy and precision, linearity, dose rate dependence, energy dependence, directional dependence, spatial resolution and physical size, readout convenience, and convenience of use. So first is about accuracy and precision. In radiotherapy dosimetry, the uncertainty associated with the measurement is often expressed in terms of accuracy and precision. Precision of dosimetry measurement specifies the reproducibility of the measurements under similar conditions and can be estimated from the data obtained in repeated measurements. High precision is associated with a small standard deviation of the distribution of the measurement results. The accuracy of dosimetry measurements is the proximity of their expectation value to the true value of the measured quantity. Next is about linearity. The dosimeter reading should be linearly proportional to the dosimetric quantity. Beyond a certain dose range, a non-linearity set in. The linearity range and the non-linearity behavior depend on the type of dosimeter and its physical characteristics. Two typical examples of response characteristics of dosimetry systems are shown in figure. Here, curve A first exhibit linearity with dose, then a supralinear behavior, and finally saturation. Curve B first exhibits linearity and then saturation at high doses. In general, a nonlinear behavior should be corrected for a dosimeter and its reader. Next is about dose rate dependence. Integrating systems measure the integrated response of a dosimetry system. For such systems, the measured dosimetric quantity should be independent of the rate of that quantity. Next is about energy dependence. The response of a dosimetry system is generally a function of radiation beam quality, which means energy. Since the dosimetry systems are calibrated at a specific radiation beam quality or qualities and used over a much wider energy range, the variation of the response of a dosimetry system with radiation quality, which is otherwise called energy dependence, requires correction. Next is about directional dependence. The variation in response of a dosimeter with the angle of incidence of radiation is known as the directional or angular dependence of the dosimeter. Dosimeters usually exhibit directional dependence due to their constructional details, physical size, and energy of the incident radiation. Next is about spatial resolution and physical size. Since the dose is a point quantity, the dosimeter should allow the determination of the dose from a very small volume. That is, one needs a point dosimeter to characterize the dose at a point. The position of the point where the dose is determined, that is, its spatial location, should be well defined in a reference coordinate system. Next is about readout convenience. Direct reading dosimeters are generally more convenient than passive dosimeters. While some dosimeters are inherently of the integrating type, some other can measure in both integral and differential modes. It's about convenience of use. Ionization chambers are reusable with no or little change in sensitivity within their lifespan. Semiconductor dosimeters are reusable but with a gradual loss of sensitivity within their lifespan. However, some dosimeters are not reusable. Some dosimeters measure dose distribution in a single exposure, and some dosimeters are quite rugged. That is, handling will not influence sensitivity, while others are sensitive to handling. In general, we can say dosimeters measure an individual's or an object's exposure to something in an environment, particularly to a hazardous environment, over long periods of time or over a lifetime.